Hey there, in this video we are talking about if-else statements, which is actually an expansion of the if statement that we talked about in the prior video. This covers Gaddis textbook sections 4.4 to 4.7. Okay, so expanding the if statement, right? Previously we saw the if statement that has an expression and controls some kind of statement. So here is the second part really to an if statement, is right after that you can have this statement else that itself controls a second statement. So this provides two separate decision branches, which is what you commonly want. If that expression up in the parentheses, notice there's only one set of parentheses, it's after the if. The else does not have any expression or parentheses after it. So if that one expression is true, what's going to happen is statement one will happen, will run, and you'll skip the else part. You'll just jump past it. But if the expression is false, then you skip statement one and you go do statement two instead, and then go on with the rest of your program. Now again, I'm just showing you two simple statements here. If you want to control a whole bunch of statements, you put down curly braces in a block, and then you can put as many statements as you want in the curly braces, and that really counts as one thing. Don't forget that the statements you're controlling get an additional tab indent. So if the main function is all getting one tab indent, and this is inside that, then your controlled statements will now have two tab indents. It's how we visually identify that control structure. Okay, so we're about to see an example of that, and we're going to have a program that indicates whether a user input integer is even or odd. So you'll declare data and do the user input and so forth, and then you'll get to this decision point, and the decision is going to check in on number modulus 2 equals 0. So remember what modulus means? It's really giving you the remainder from a division, okay? So if you divide a number by 2 and the remainder is 0, that means the number was evenly divisible by 2, right? If that's true, then we're going to indicate that the number is even and then go on with the rest of the program. But if the remainder wasn't 0, if the remainder came back 1 is the only other option, then apparently the number was not evenly divisible by 2. This expression would be false, and we're going to indicate that the number is odd instead. All right, pretty simple, and this is a good example of using the modulus operator. But what we're focused on are these two separate control structure decision branches is really the important thing. Okay, so this is program 4.8 in the book. This program uses the modulus operator, for what it's worth, to determine whether a number is odd or even. If the number is evenly divisible by 2, it's an even number. Otherwise, some kind of remainder indicates it's odd. So declare data for the number, right? Here comes the input part. Prompt the user, enter an integer. I'm going to tell you whether it's odd or even. They send it in. And then here on lines 14, 15, 16, 17, right, there is our if-else statement right here. And if number mod 2, if the remainder is 0, we're going to print out your number is even. Otherwise, we're going to print out your number is odd. Pretty simple. Okay, let's test program 4.8 here. I just grabbed this out of the Gaddis textbook code archive. And again, this is just going to identify whether an integer that the user types in is even or odd. So I will compile it. And of course, no errors, no warnings. That's good. Now, I'm going to want to test this at least twice. I'm going to want to make sure that your number is even message is working correctly. And I'm going to want to make sure that your number is odd message is working correctly. So at least twice, if not more than that. What can I type in to trigger your number is even message? Like maybe 6, and it says 6 is even. So that's working correctly for that particular input. And what can I type in to trigger the other message? Like maybe 13? Yeah, 13 is odd. That's good. So it looks like the program's working correctly for those. But there's a lot of other integers, obviously. And those are both kind of small numbers, and they were both positive. So, maybe I should try a larger number. Maybe I should try a negative number. Maybe I should try 0, right? Integers can be positive or negative or 0. Really, I ought to test all of those things. So maybe I'll test something really big like 1024. Okay, that's even, right? Remember, you can just look at the last digit, right? If the last digit is 0, 2, 4, 6, or 8, that's got to be an even number. So I could try larger stuff than that. Let me try a negative, like -5. Is that even or odd? Well, it is odd, right? If you take -5 and divide by 2, you get -2.5. halves. That's not an even division by 2. That's clearly odd. And I also ought to try the number 0. You know, a lot of people, if you ask them, is 0 even or odd, they have trouble with that. Some people say both. Some people say neither. Do you know? Is 0 even or odd? You know, it actually is even. If you take 0 and divide by 2, you get a whole number, namely 0. There's no fraction. There's no decimal when you divide that by 2. So actually 0 is even is the correct answer. It's not odd. So as far as I can tell, this program does seem to be working correctly. And I checked, you know, even numbers, and I checked odd numbers, and I checked positives and negatives and 0. And this looks like a quality program. But let's dig into this a little bit more deeply. I really want to make sure that we fully understand exactly how our control structures like an if-else statement is actually working. So what I'm going to do here is I'm going to start using the debugger. And if you remember, the debugger allows us to slow a program down so we can expect exactly what's happening one line at a time. Now, in order to do that, I need to start with a breakpoint, because normally the CPU takes your program and runs, 4 billion lines at a time, which is too fast for a human to see. So right here on line 11, I'm going to say just pause, take a breather here, and we're going to inspect exactly what's happening. So now I can hit the debug button over here, and I get a console coming up. The program is currently running. Nothing has been printed to the console yet. Make sure I have enough room here to see it. Because we paused it at line 11. Now if I go down here and hit next line, it's just going to do line 11 and then pause at the next line, which is obviously 12. Great. So line 11 just happened, and sure enough, it printed enter an integer, and I will tell you if it... Okay, so now we're on line 12, and I hit next line, and it prints is odd or even. Great. Now, the next thing that's about to happen on line 13 is we're going to ask, we're going to syn in to this number variable, and what I can do here is I can add a watch and actually see what's in that variable specifically. So I'll add a watch and say, yeah, let's watch this number variable. And that pops up over here in the debug tab. Now, little interesting reminder, remember, when you make a new variable, if you don't initialize it, it's holding random garbage. Could be anything. In this particular case, it just happens to be holding the number 4,242,448. No way I would have been able to predict that. Really could have been anything based on what prior programs were using that memory slot. If I do this again later on in a couple hours, I'm sure that'll be different. I'm sure if you run this at home, you'll get a different number there probably. But a good kind of reminder, we haven't initialized it, so just whatever was sitting there before is still sitting there. I'm going to run line 13 here. Okay, line 13 is happening. So now the console is expecting me to actually type something in, like maybe I'll type in 6. Enter. And you can see that goes into the number variable. It replaces what used to be there. That's what always happens with an assignment statement. And now we're on line 14, and line 14 is about to happen. And it's going to check in number mod 2, because if I divide by 6, what's the remainder? It's 0. Is 0 equal to 0? Well, that's true. So the question is, what line do we go to now? Okay, and if an if statement is true, you go into the controlled statement, which is namely line 15. Here you go. So obviously we're about to print out, your number 6 is even. But the question I'm really interested in is, and that's a couple things. It's got to print the number. It's got to print the is even text. But my question is, where's it going to go then? What line will we go to after line 15? Do you know? Right? And the answer is, if you do the if part, you're going to skip the else part. So we're going to skip down to line 18 is the next thing that's going to happen. All that stuff in between, we just jump over it. So let's see that happens. It's printing the number, printing the text, right? Line 15 right now. Now we're on line 18. Right, it printed 6 as even, we knew that, but the important thing is we skipped over the else part, and that's what happens in an if-else statement. Okay, and then of course, you're returning out of the function, we're getting out of the main function, there's some cleanup work, and sending control back to Windows, and the program is over. Let's try that again. Let's try that again with an odd number. So, hitting debug here. Notice once again, as the program starts up, you got random garbage in your variable there, not too surprising. So the program flow goes 11, and then 12, and then 13, right, entering something here. Type in, 17, just for argument's sake. So the 17 goes in a number. We're doing line 14 right now, checking number mod 2. So if you divide 17 by 2, you get a remainder of 1. Is 1 equal to 0? That is false. So my question is, what line are we going to next? Right, we're going to skip over line 15. We're going to go into the else block. And what you're going to see is we're just going to jump right down to line 17. Inside the else block is how this displays it. So I hit next line, and we're on 17. Right, and that's what happens if your expression is false. And so in this case, it prints out, right, number is odd, like that. And then it just goes on with the rest of the code. It hits line 18. We're returning out of the function back to Windows, and it does the cleanup work, and the program is over. So I think that's kind of useful to occasionally, like the first time you see a new control structure particularly, use the debugger, actually step through it in different cases and actually see exactly how it jumps around. For decisions, like we said in an introductory video, the question is basically, where are you jumping down to skip stuff? And if the expression is true, you're going to skip the else part. But if the expression is false, you're actually going to just skip the initial if part. So hopefully that's helpful. All right, let's get a little bit more advanced. Let's look at nesting if statements, more than one if statement actually. So you can place an if statement inside the block of another if statement. That's perfectly permissible. You can put anything inside the block of an if statement. Declarations, counts, sins, calculations, whatever. Other if statements is also acceptable. Anything is. More generally speaking, nesting, right, means putting something inside of something. And you can do this for lots of, like any different control structure in C++, you can do this. So kind of be aware of that as we go forward. You put something inside something, that's called nesting. In theory, there's no limit to how many levels of nesting can occur. If you have very complex decision structures, like in a business, you might have an if statement in an if statement in an if statement in another if statement. The code that I've worked on professionally, I think the very first day, someone showed me a block of code that had like ifs nested about 10 or 12 levels deep before they got done. So I was like, wow, that's a lot of if statements right there. We're not gonna do anything that crazy. We'll probably at most have 2 or 3, but we should see an example of that. Okay, so the next example you're gonna see as we look at it here in flowchart form, I think the example is hypothetically, let's say there is a low-cost loan available only to people who are now working as fresh graduates out of college. I don't know if this is real or not, but for the purpose of the example, that's it. So in order to get the loan, notice that you need 2 things to be true. You need to be a recent college graduate and you need to currently have a job. So what's going to happen in our program is you declare data, get the user to answer these 2 questions, and then you'll have a first decision point of checking whether they said yes to the employed question, right? They're just going to type in either Y or N to indicate yes or no will be their input. So if employed, we're going to check in, is employed equal to Y, equal to yes? Do they say they have a job? If that's false, they're not allowed to have a loan. So we'll take this branch and we should get a message that says, you must be employed to qualify. You don't get the loan. And then it will go on to the end of the program. But if that employed question was true, right, now we can check in on the second question and see whether they said yes to the are you a recent graduate question. Now, if that's false, the program should display, you must have graduated from college in the past 2 years to qualify, okay? And then go on to the rest of the program. But if that second question is also true, then you'll get the message, hey, you qualify for the special interest rate loan. And then go on with the rest of the program like normal. Okay, that's what should happen in this example here. So this is program 410 in the book that does that. This program is here to demonstrate the nested if statement. And kind of standard stuff to begin with, 2 character variables to receive the Y or N responses for yes or no. You have a standard input block here from line 10 down. Answer the following questions with either Y for yes or N for no. We prompt the user. Are you employed? And they send in Y or N for answer to employed. We prompt, have you graduated from college in the past 2 years? They send in that. So there's our input block, fairly large input block. Now, I'll point out, as usual, we just have one short little comment to summarize for the reading programmer what all this stuff is doing. Right? It says, is the user employed and a recent graduate? That's the goal of all those lines. So I didn't write this program. It's right out of the book. but I agree with this styling. That's a very clear comment that gives a nice overview for all that stuff. But the thing that we're really interested in is this if statement down here from line 20 down to line 28, right? Nested if statement. So first of all, in line 21, you check in, is employed equal to Y? If so, you get into this block here. I think this example is a little bit abbreviated compared to our flowchart just for space purposes. I don't think this actually prints the no results. It just has one printing for the yes result. But if 21 is true, then you go into this block and you notice that we have curly braces right here from line 22 to 28. They're lined up, right? The control part of that if statement is really all that stuff from line 22 down to line 28. So if it's true, you go in there to line 23, and that's another if statement. There's your nested if right there, an if inside an if. So you check in, is recent grad equal to the character uppercase Y? And if that's true, right, here's another block. Here's a curly brace, right? So this block goes from line 24 to 27. You're going to do all this stuff. So if you pass both of those checks, then you land on line 25, and it prints out, you qualify for the special interest rate. Right? Notice there's actually two separate printing statements. In order to have that happen, I needed to have those two curly braces. If that came back false, like if they'd said no to recent graduate, they would have skipped all this stuff. They would have skipped line 24 and 25 and 26 and 27 and not seen that positive message and just gotten to the end of the program that way. Now notice with the nested if, right, every time you get into a new control block, you get one more tab indent to represent that. So if you're on line 25, you now have 3 tab indents, right? One from the main function, one from the first if statement, and now one from the second if statement. So now you've actually got 3 tab indents. And it's very easy to see that these lines 25, 26 belong in the control of this second if statement. Now, we do the tabs for human readers, human eyes, right? What the computer pays attention to is these curly braces, which is a little bit different. But again, we wanted those lined up because that's what really indicates that there's one single control block for this second if statement. Pretty good example. Okay, so we should test this program for 10, the example of the nested ifs here. Our programs are getting a little bit more complicated. So I want to be really careful and make sure that I cover all the possibilities of kinds of user input. So before I actually start dealing with the program, I'm going to use a test script and make sure I understand what could happen here. So I've started this, I've written it in hand, of course. This program has 2 pieces of input. You ask the user if they're employed, you ask if they are a recent graduate, and you can get a Y or N for either of those things. There's going to be 1 piece of output, basically, do you qualify for the special loan or not? And with these 2 questions, these 2 if statements, they combine together in 4 possible ways, 4 combinations that the user could actually enter input. They could say yes and then yes. The user could say yes and then no. They could say no and then yes, or they could say no and then no a second time. So again, when you have a Boolean, 2 possibilities, you put them together, the number of combinations multiply. So I do have to realize that there's 4 different things that could happen here, and I do need to test my program 4 times to make sure that the result is correct in every single situation. Now, of course, in order to confirm that, we as human beings need to know what the right answer is in advance, which is what I'm filling in right now. So hopefully you remember how that example was set up. If the user says, yes, I'm currently employed, and yes, I'm a recent graduate, then the answer is, do you qualify, is, well, it's yes. That's actually the whole point to the special loan. Now, if they say, yes, I'm currently employed, no, I'm not a recent graduate, then the correct response should be no. Okay. If they say, no, I'm not employed, yes, I'm a recent graduate, the response should be no. Okay. And then if they say, no, I'm not employed, no, I'm not a recent graduate, then the response should also be no. Right? The whole point of the special loan is it only goes to people that are both currently employed and recent graduates. So there's my test script, and I'm just going to pull this to the side now. I'll keep an eye on it, and I know I need to test this program 4 times to really confirm that all these possibilities are working correctly. So just pull that over the side, keep an eye on it. Now I'm looking at the code in my IDE. I can compile it. Great. And now I'll start running it. And I'm just going to put in exactly those things on my test script there, those 4 test cases. So the first one is, what if they say yes to employed and yes, I have graduated from college in the past 2 years. Okay, and yes, we do in fact get the message that says you qualify for the special interest rate. So this looks like it's working correctly. Now, as a little side note, the way this program is set up is I've got to be careful and use capital letters for the input. This program only handles capital letters. Later on, we'll see some options for handling either capitals or lowercase, whichever the user wants to enter. But right at the moment, we don't have that capacity. Just like it's the next lecture, frankly. Check in on the next video and you'll see how to do that. But that's just the first test case. And now I got to do the other ones. So the second one was, what if they say yes and then no? And no, we do not get the message about getting the special interest rate being qualified for. So this looks correct to me. And the third case was, what if they say no and then yes? Okay, and no, we do not get the message about qualifying for the loan. So this is correct. And then finally, what if they type in no and no? Okay, no, we do not get the message about the special interest rate. So we tested all 4 possibilities, and it looks like we're getting the proper response every single combination of inputs. And that's what you need to do. As you have more if statements and you have more conditionals, you do want full test coverage and confirm that every single combination of user inputs is working correctly. And that can get very complicated in a much larger program. But this is good enough for us for now. Program looks solid to me. Now let's expand on that. So you can actually chain a bunch of if-elses together in what's called an if-else-if statement. You might see something like this. Okay, so you see if expression 1, here's the first statement, else if expression 2, here's the second statement, and you can have another else if, and you can have another else if, and you can have another else if. And then at the end, you'll probably have one more else. Remember, right after an else, you never have parentheses or an expression. So this is a bunch of if-else statements being chained together. And really, this is the same thing as nested ifs. Okay, I have an if statement, great. Okay, it was one statement. And then here's an else block. What's in the else block? Another if statement. Okay, that's perfectly fine. It's really just nesting written a little bit differently. Here's another if statement that controls statement 2. And presumably right after that, where my ... is, there's an else. What's in that else? Another if statement. Perfectly fine. You can nest stuff 3 deep like that, right? And there's an if and there's an else. What's in that else statement? Probably another if. And so you can keep chaining these together as long as you want. And don't forget that right at the end, you're going to probably have one last else, and that finally doesn't have an if statement in it, and just has one more statement in it. So if you think about how that works, only one of these statements can possibly execute. Because if this very first if is true, you'd run statement 1, and of course you would skip the else part, which is all of the rest of it, right? On the other hand, maybe expression 1 was false, okay, so you land on this else, you check this if, maybe this if is true, you run statement 2, and then you would not do the next else, which is actually containing everything in the whole chain, right? And you just jump all over that stuff and only do statement 2 in that case. So only one of these statements would ever execute in the chain. Again, I'm just showing you single statements being controlled. You could replace that with a curly brace block if you wanted to take a more sophisticated action. And you're probably going to have one last trailing else at the end that's probably there to catch errors, to say, hey, all this possibilities that we expected to happen, none of those happened, and maybe there's some kind of error that you should pay attention to. So that is what's called the if-else-if chain. But really, it's just a bunch of nested if-elses is all it is, right? A slightly different way of writing it to make it look neat on the screen. So here's program 414 in the book, pretty good example of what we're talking about. This program uses an if-else-if chain statement to assign a letter grade to a numeric score. So students in the class usually are accustomed to getting an A, B, C, D, or F letter grade, depending on what their number was. So first of all, we set up some constants for the cutoffs for the different letter grades. So for an A score, the cutoff is 90. If you get a 90 or above, you're going to get an A. The B score cutoff is 80. C score is 70. D score is 60. So, these are fairly common letter thresholds for college courses. Not every college does it the same way, not every class. For what it's worth, these are the exact same numbers that I use in my class for grading for the letter grade cutoffs. So even without me having written this example, yeah, this is the same thing that I do, fairly common. Here is a variable called test score to receive the user input for a number, right? Standard input block, we prompt the user, enter your numeric test score. I will tell you the letter grade you earned, and we send the number in the test score. So just all, standard stuff. The interesting thing is on the next slide of what we do with that. So here is a big if-else-if chain. And you can see there's an if-else-if followed by another else-if followed by another else-if, etc. So you get into this block of code hypothetically, and you check, first of all, if the test score is greater than or equal to the A score. So let's say someone had a 98. Okay, test score greater than 95. That would be true. You'd go to line 23 and print out your grade as A, and then it would skip the else part, which is all of this other stuff, because these are really just a bunch of nested if statements. So this else is all the way from 24 down to 33. You'd skip all of that stuff. You'd land on 35. The main function would return back to Windows or your operating system, and the program would be over and would only print the grade as A. Right? Now let's say someone had a 75. Okay, so you'd get here, line 22, is 75 greater than or equal to 95 false. So you skip over line 23, you don't do that. You go to the else statement. Okay, what's in that else statement? It's another if. Okay, and you check in, is 75 greater than or equal to 85? Well, it's also false. So you're not going to do line 25. You're going to go to line 26. Okay, what's in that else statement? Oh, it's another if. And you check, is 75 greater than or equal to 70? Well, that's actually true. So that if statement, you will do line 27, print out your grade as C, and you will not do the attached else, which is actually all the rest of the stuff. So at that point, you jump over line 28, 29, 30, 31, 32, 33. You wouldn't do any of that stuff. Land on line 35, return out of the function, the program is over. And it only printed your grade as C. Right? You can kind of see how that would work for all this stuff. Now, I'll draw your attention to this trailing else, right? If none of that stuff works, you're going to land on this trailing else, and the only way that's going to happen is you've had to have a negative number, which isn't really a legitimate score in the first place. So in that case, it's going to print out invalid test score, and that's generally what you use that trailing else for, to catch error situations, or in this case, an invalid test score. To get there, you'd have to have like a -5, which doesn't make any sense at all. And line 22 would be false, and -5 is not greater than or equal to 80, and it's not greater than or equal to 70, and this is false, and it's not greater than or equal to 0, and then you'd land on line 32, 33, and you'd get this error message. Okay, so again, don't forget, there's going to be a trailing else. There's no if there. There's no expression there. You never have an expression after an else. That's the last thing that can possibly happen if none of the other statements executed. All right, so that's the story of if-elses. You can just use a single if-else, right? You can nest ifs and elses inside each other, and you can actually use that to chain a whole bunch of them together, like in that last example, an if, else if, else if, else if chain. So at this point, my students, the next time we get in person, we do this lab here on grades, kind of like we were talking about a little bit, and getting accustomed to the if-else and watching out for some errors, and then also modifying the program at the end. Of course, we would start by writing a test script as usual to think about all the different situations, all the different statements that could happen, and make sure that we confirm they all work correctly. One thing I do is I make sure to test the boundary condition. Frequently, the most common places for errors are right at the cutoff. So in the example we just saw, like, what grade should you get if you get exactly a 90? Right, that is the threshold between a B and an A. So what grade should you get if you get exactly 90? And the answer should be you get an A. So frequently I want to have that on my test script, because it's very common and very easy to write a program that does everything else correct and then bungles the boundary condition. So ideally you've got that in your test script and you make sure that you test that. So I'm going to have my students do that. You know, if you have access to the lab code on your own and you want to do this, that's great. And you could even like expand this lab in a couple ways. Like you'd expand it to have the error condition that we were talking about. Like what if someone types in a negative number? Can you get an error message? You know, skip all the other messages and get an error message that says that's an invalid score. You might try that. You know, honestly, the first time my students, you know, find that a little bit challenging. Actually, the first time, maybe it'll be very easy for you to do that. But that's what we would do in our next lab. In the next video, we're going to be talking about logical operators, the logical operators of not and or that actually allow you to combine multiple Boolean expressions. We've talked about Booleans before. That's actually, you know, what's triggering your if-else statements. So now we can expand on that, actually combine multiple Boolean expressions together in interesting ways with these connectors that are called logical operators, and, or, not, stuff like that. So that's kind of interesting and allows us to make more sophisticated programs, and I'll see you then.